Alright, Year 10, so for Thursday and Friday, we're moving on to a second way to solve simultaneous equations, and it's called the elimination method. So these are the notes you can put into your summary book. So we use substitution method when one of the equations had a y equals or an x equals, and you could substitute it straight in. For the elimination method, it's going to be when your variables pretty much are lined up. So if you have a look at these two equations, I've got my two x's that are sort of lined up, my y's and a constant on the other side. In the second equation, I've got my x's pretty much lined up, my y's and a constant on the other side. So we're actually going to either add or subtract our equations, and that should allow one of the letters or one of the variables to be eliminated. So the first part of it is a different method, but once we get one solution solved, it becomes just like the ones we did the other day. So I'm going to show you three different types. So in the first type of example, I'm going to write them one above the other. It makes it a little bit easier to see. X plus y equals 6, and we've got 3x minus y equals 10. So the easiest sort you could have, you're looking at the numbers in front of x and in front of y, which are called the coefficients. You're looking for ones that have the same coefficient. So if I look at the x's, one has a 1, the other has a 3, not the same. With the y's, one is positive 1, one is negative 1. That's what I'm wanting to use here. I still label them equation 1 and equation 2 like I did the other day. And I still explain what I'm going to do. I'm actually going to take equation 1 and I'm going to add equation 2. And the reason I'm going to do that is if I look at these coefficients here, I've got a plus 1 and I've got a minus 1. So if they're the same number, different signs, so I'll just put a note here. If they are different signs, all I need to do is add the equations. If they were the same side, you would subtract. Okay, but in this one, all I need to do is add them, and you'll see on my line of working on the next line why this works. So I'm going to write out equation 1, and I've said that I'm going to add equation 2. I'm going to set it out like a sum, like you would have done in primary school. It sometimes makes it a bit easier to see. And then you add up all the things that are lined up. So the x plus the 3x, that's 1x plus 3x, that's 4x. 1y, when you add negative y, it cancels out. It's 0y, you don't even bother writing it. Line up your equal signs, 6 plus 10 is 16. And from there you can solve that. If 4x is 16, then x is 16 divided by 4. X has a value of 4. And now it becomes like the second part of what we did the other day. Call that number 3. And I'm going to sub 3 in, and it doesn't matter which equation you put it in. I might just put it in equation 1. It will work for both. You'll get the same answer no matter which one you put it in, so don't stress about which equation you put it in. So equation 1 was x plus y equals 6. So instead of x, we've just solved. X is now 4, so it's 4 plus y must equal 6. Rearrange to get y. Y has a value of 2, and that's my simultaneous solution. So my solution is when x is 4, y has a value of 2. So it's, if I was to graph those two lines, they would intersect at the point 4, 2. It's the one value for each of x and y that satisfies both of the equations that they gave you to start with. Okay, so that's pretty much the elimination method. You're going to add or subtract your equations or combinations of them, multiples of equations, so that one variable's eliminated, so you can go ahead and solve for one variable. That then allows you to find the second variable. So I'm going to do two more. They're a little bit different. This is the simplest type where you can just add or subtract. It's not going to be that simple in the next one. Let me start by writing them. Y minus 3x equals 1 and 2y plus 5x equals 13. Label them equation 1 and equation 2. So remember, I'm looking at the coefficients in front. In front of the y, I've got a 1 and a 2. In front of the x's, I've got a negative 3 and a positive 5. I've got to make the coefficient the same for one of the variables. So either I could take the x's and turn them both into a 15, because 3 and 5 each go into 15, but it's actually going to be quicker to take equation 1, times it by 2. That would get me a 2y at the front. And I'm actually just going to do equation 2 minus 2 lots of equation 1. you could do it the other way around with the subtract. However, looking at the second equation that has a 13 in it, I think I might like to have a bigger number minus a smaller number. So let me show you what this looks like. So I've set equation 2. Let's write out equation 2. And we're going to subtract. Now I've got to double everything in equation 1. So I've got to double the y, double the negative 3x to make minus 6x, and double the 1 gives me 2. Set it out as a sum, and what should happen is that the y's are eliminated. They cancel out. In this case, because I had positive y and positive 2y, if they are the same sign, this time I subtracted the equations rather than add them. So if they're the same sign and you want it to cancel out, you've got to subtract. So from here, 2y minus 2y is no y. You don't bother writing it. The 5x minus negative 6x is going to turn this into a plus here. So 5x and 6x is 11x. And then 13 minus 2 is going to give me 11. So remember, everything was minus. It's just the minus negative turns into a plus. Divide through by 11. X must have been 1. You should be familiar with these steps. Sub it into either equation, doesn't matter which. Therefore, my solution, or my simultaneous solution, when x is 1, y is 4. So if I was to graph the two lines on Desmos, they would intersect at the point 1, 4. Right, so in this example, we had to change just one of the equations by multiplying it through by the same value to get the coefficients the same. So the final example, you'll find that none of the coefficients line up and you have to change both equations and combine them together. Start by writing them out. 3x plus 2y equals 6 and 5x plus 3y equals 11. Label equation 1, equation 2. So if I have a look out the front, my x's I've got a 3 and a 5. With my y's I've got a 2 and a 3. It doesn't matter which one, but I've got to make the coefficients the same. I might just make the y's the same because it'll create a smaller number. So I'm going to take equation 1 and I'm going to multiply everything there by 3. And I'll subtract equation 2 if everything's multiplied by 2. So by timesing equation 1 by 3, I'll end up with a 6y. And by timesing everything in equation 2 by 2, I'll end up with a 6y. And because they're both 6y, I need to subtract. They're the same sign. Let me set that out so I haven't multiplied. Equation 1 by 3, everything gets multiplied by 3. And I'm subtracting. Now everything in equation 2 is getting doubled. I didn't worry this time about the positives and negatives. Just want to show you can do it either way. The 6y's will cancel out this time. So on the left, 9x minus 10x is negative 1x. And 18 minus 22 is negative 4. So positive x must have been positive 4. If you're not sure how to rearrange that, divide both sides by negative 1 to get rid of the negative. So that's equation 3. Sub 3 back into one of those original equations. Let's put it in equation 2, not that it would matter. So we've got 5 lots of x, which we've now found is 4. So if 20 plus 3y equals 11, 3y must be 11 minus 20, which is negative 9. And y equals negative 9 divided by positive 3, which is negative 3. So our solution is that x equals 4, y equals negative 3. Again, if you were graphing it, where those two lines meet, it would intersect at the point 4, negative 3. 4 on the x-axis, 3 on the y. Now I haven't been doing this with either of our equations, but just keep in mind you can always do a check. So if 4, negative 3 satisfies both equations, it works. So if I take 3, so I'm looking at this one here, 3x plus 2y equals 6, so 3 lots of 4 plus 2 lots of y, which is negative 3. If I work that out, I get 12 minus 6 gives me 6, which is what they said it equals. Check that it works in the other equation. 5 lots of 4 plus 3 lots of negative 3. 20 minus 9 is 11, and that's what equation 2 was. So you can always check and make sure it does give you those values. Exercise 1J, I've selected out some set work. I've highlighted them here. You can always do more from those earlier questions if you feel the need to do that. So 3 to 9 is the ones I'd like you to do. And I've set 10 and 12 as extension. Just note 13, some of you might be interested to try that. It's actually a topic that I've only just done in the last couple of months with Year 12 Specialist Maths. So you would only ever see those questions in number 13 if you do Specialist Maths down the track. So if you are planning on doing that and you get through those earlier questions, might be worth having a look at those and seeing if you can follow the steps of what they've done. Okay, so good luck with your with your elimination method to solve your equations.